So here we want to find a specific term when we expand a binomial. So we have this binomial x plus 2 raised to the 8th power, which would take us forever if we're going to do this by hand. X plus 2 times x plus 2 times x plus 2, 8 times. But we can use the binomial theorem to expand this out. So as a reminder, our binomial theorem, this real ugly looking thing, I have a plus b raised to the n, is saying, well, if I want to expand, the formula is, well, I take the sum from k equals 0 to n, whatever this exponent is, of n choose k, which is just this n factorial over n minus k factorial times k factorial from our combinatorics, times a raised to the n minus k, b raised to the k. So this is saying I'm going to plug in 0 up to n for n and k to give me each of these terms. So for example, if this n is equal to 3, my first term is going to be 3 choose 0, right? I'm going to plug in 3 here. I'm going to plug in 0 here. I'm going to plug in 3, 0, and 0, and it's going to give me this first term. And then I will do the same for each subsequent term. 3 choose 1. This would be 3 choose 2, and so forth. Well, I don't need to expand the whole thing for this problem. I just need a specific term. So instead of using this sum portion, I just need to use this portion of my formula, which looks like this. For the k plus 1th term of a plus b raised to the n, now, is going to be your formula n factorial over n minus k factorial times k factorial times a raised to the n minus k and b raised to the k. So I can find whichever term by just plugging in numbers for n and k, depending on the term. So it is the k plus 1 term rather than the k, because notice on my very first term, if I were to expand this out of this particular expansion where a is equal to, I have a is equal to x, b is equal to 2, and n is equal to 8. When I plug it in the pattern using my Pascal's triangle, I get 1 for my coefficient, and then a raised to the 8th and b raised to the 0. So the first term, b, is the 0, right? So if I plug in 0 for k, I get 0 plus 1, or the first term. So that's why we have this k plus 1th term. So I need to identify what is k plus 1. Well, it says we're looking for the 4th term. So k plus 1 equals 4, meaning that k must be 3. And once I have all these pieces, it's just plug and chug from there, because I have n, which is here, and I have k, which is here, and then I need a, and I need b, and it's just plugging in the values and simplifying. So here we go. N is 8, so I would say 8 factorial divided by n minus k, which is 8 minus 3 factorial, times k factorial, which is 3 factorial. And a, again, is x raised to the n minus k, which is raised to the 8 minus 3. And then b, which is 2, so 2 raised to the k power, which is 3. So here I have. All I have to do here is simplify now. So I could either plug this into my calculator or do it by hand here. If you notice by hand, it's just going to be 8 factorial is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1, all divided by, and 8 minus 3 factorial is 5 factorial, which is 5 times 4 times 3 times 2 times 1. And then another 3 factorial, which is 3 times 2 times 1. And then it's just simplifying from there. Well, 3 over 3, 2 over 2, 1 over 1. Those cancel. I've got 5, I've got 4, and then 6, which is 3 times 2. And I'm just left with 8 times 7 over 1, which is the same thing you get if you just plug it into your calculator. So this simplifies to 56. Then x raised to the 8 minus 3 is x to the 5th. And then finally, 2 raised to the 3rd is 8. And the last thing I need to do is just multiply 8 times 56. And my final answer is 448x to the 5th is the 4th term of this expansion. So if you did the whole expansion, you would see that the 4th term is 448x to the 5th.